Now we will discuss about average velocity. Whenever a body is moving, it is not said that it must be moving with a constant velocity and in a particular direction. So, it is defined as the ratio of total displacement to the total time taken for that displacement. So, and it is also a vector quantity being a velocity. Okay. Being velocity, it is a vector quantity and it depends upon direction also, and its direction is in the direction of displacement. So average velocity depends upon the direction of displacement. At last we will discuss about instantaneous velocity. Instantaneous velocity is a velocity of a body at a particular instant. Means it is the actual velocity of a body which is moving at a particular time and in a particular direction. So it is defined as now we will discuss about another physical quantity, that is acceleration. It is denoted by small a. Now, as we have discussed about velocity and we have seen that it is a vector quantity, so it is dependent on value and direction. Change in either of them will change the velocity of a particular body. So that change in velocity which is taking place is taking with respect to time. So that change in velocity with respect to time is termed as acceleration. So it is defined as rate of change of velocity, or it may also be defined as change in velocity with respect to time. Mathematically, it can be calculated by using the formula, that is change in velocity divided by time. Here A is equal to V minus U by T. In this formula, V is for final velocity, U is for initial velocity, and T represents the time in which the above velocity change occurs. Its SI unit is meter per second square. Now we will discuss about types of acceleration. As we said, A is V minus U by T. Now, in this case, first, if V is greater than U, then A will be a positive quantity. So, whenever final velocity is greater than initial velocity, it is termed as positive acceleration. But in second case, if final velocity is less than initial velocity, then A will be negative. So, in this case, we say that the acceleration is negative, which is termed as retardation. If in numerical problem we get a word retardation, then it is self-understood that A has to be taken negative. So whenever the body is retarded, it implies that its initial velocity is greater than its final velocity. Now we will discuss about uniform acceleration and non-uniform acceleration. These were the two types of acceleration which we have discussed just now, that is positive and negative. First we will discuss about uniform acceleration. First we will discuss about uniform acceleration. As we said that acceleration is change in velocity, so uniform acceleration is said when body changes its velocity in equal amount, that too in equal interval of time. So whenever such case happens that a body is changing its velocity in equal amount and in equal interval of time, then it is said that the body is having uniform acceleration. So now we will define it as now we will define non-uniform acceleration. Non-uniform acceleration is defined as whenever velocity increases by unequal amount but in equal interval of time. Means there is change in velocity which is unequal, but the change which is taking place is in equal interval of time. So now we will discuss about the equations of motion. There exist three equations of motion, but these equations of motion are applicable only to uniformly accelerated motion. So, in the case when there is acceleration is not changing, there is uniform acceleration, these three equations can be applied to calculate various parameters which are involved in these three equations. So, we will discuss about first equation of motion. For first equation of motion, let us consider that a body is moving with some velocity, that is initial velocity, which is denoted by u, and there occurs a velocity change and it attains a final velocity that is equal to v. So initial velocity is u and final velocity is v. That is taking place in time t. So t is a time when body changes its initial velocity, that is u, to final velocity, that is v. So if there is a velocity change, then there exists acceleration, that is a, which is defined as change in velocity. So here change in velocity is v minus u per unit time, that is t. So by cross multiplying this, we get at is equal to v minus u, and by various substitutions we get v equals to u plus at, and this v equals to u plus at is a first equation of motion, where v is final velocity, u is initial velocity, a is acceleration, and t is time. Now we will calculate or evaluate the second equation of motion. For second equation of motion, again we consider that v is final velocity, u is initial velocity, and t is time. In this case, first we will discuss about the distance. Distance is speed or velocity into time. As we have said that there exists final and initial velocity, then there must be average velocity. Average velocity is equal to v plus u by 2. Here distance is represented by s. So distance will be v plus u by 2 into t. So s will be equal to vt by 2 plus ut by 2. But in the above case we have studied that v is equal to u plus at. So substituting this value of v in above equation, we get u plus at into t plus ut divided by 2. On solving this, we get twice of ut plus at square divided by 2, and s will be equal to ut plus half at square. This is the second equation of motion, where s represents the distance, u initial velocity, t time, and a represents acceleration. Now we will discuss about the third equation of motion. For the third equation of motion, again we have v equals to u plus at, that is equal to first equation of motion. Here if we evaluate the value of t, we get v minus u by a. Substituting this value of t in this formula, that is distance equal to average velocity into time. Here s is equal to v plus u by t into t. Substitute the value of t from above in formula of s. We get v plus u by t multiplied by v minus u by a. And on solving this, we get v square minus u square by 2a. Cross multiply this, we get 2a is equal to v square minus u square. So this is the third equation of motion. So by using these three equations of motion, we can calculate the various parameters which are involved in these equations, and the condition for these equations to be applied is that the acceleration should remain constant. It should not be changed.